Hello students, so today we are going to start chemistry of 10th standard. These chemistry topics of 10th standard are very interesting provided you understand the concepts. I am going to explain concepts to you in great detail. In case you have any difficulty, you can ask me, but don't do mugging, but try to see that you are doing by understanding the concepts. This chemistry is an introduction to 11th and 12th chemistry. If you are not able to understand 10th standard chemistry, it would be difficult for you to understand 11th and 12th standard chemistry. As you know, chemistry has main three branches: physical chemistry, inorganic chemistry and organic chemistry. In physical chemistry we will be learning periodic table and chemical bonding. Then we will go to mole concept and straw chemistry. These are very important topics which will be continued in 11th and 12th. In inorganic chemistry, besides learning the compounds hydrochloric acid, nitric acid, sulfuric acid, ammonia, we will be also learning acid, bases and salt and metallurgy. Metallurgy is a very big topic and quite interesting topic. Other topic is electrolysis. All these topics are quite easy and interesting, provided you understand their concepts. Then we have to study about organic chemistry, as we will be making a beginning of this. So this portion is also quite big, but if you understand the nomenclature and how organic chemistry is built up, you will find it quite interesting. Now, previous year you might have studied about structure of atom and its properties, but due to pandemic, in case I have not understood those concepts clearly, I will first revise those concepts because they are required to understand periodic table. So, now with this introduction, let us begin our study. So first, as I told you, I will revise first let us go through the syllabus of periodic table that we have to study. So we have to study the modern periodic table up to period 3. Further I will explain you, it would be quite interesting to understand the full periodic table. It is going to be in great depth we will be studying in 11th standard. Then we are going to see the important periodic properties, how does they vary along the period and down the group. So this is in nutshell the syllabus of periodic table, and we have to explain the change in properties on the basis of nuclear charge and nuclear size. So now we will study, we will revise 9th standard physics. You have learned atomic number means number of protons. It is denoted by a letter Z. The short form of it is that we will write Z for atomic number. So this is, you should learn that atomic number is written by Z. Okay, atomic number is written by Z. So this is atomic number in brief. Mass number is written by capital A. Mass number means number of protons and neutrons. Now, I also remember that how is the atom made up of? Atom has got a small space called nucleus. This is called nucleus. Inside the nucleus we have these protons and neutrons. So inside the nucleus we have protons and neutrons. Now mass of both of them are almost same. So we say their mass is 1 atomic mass unit. You can just remember one. Proton mass is 1 atomic mass unit, neutron is 1 atomic mass unit. So whatever is the total, that is mass of the atom or nucleus. Because mass of electron is very very small compared to mass of proton and neutron. It is 1/1840. Now electrons are rotating in various orbits around the nucleus. So electrons are rotating in this orbit. So that are denoted by negative sign because electrons carry negative charge. So you have to remember that electrons has negligible mass and they have negative charge, and protons have positive charge equal to the charge of electron but of opposite polarity. Neutrons have no charge, so they are called neutral. From neutral, neutrons have come. So this structure of atoms you should remember. So if somebody says if atomic mass number is A, atomic number is Z, how many neutrons it has? It is A minus Z, because A is number of protons and neutrons and Z are only protons. So in this manner we can calculate number of neutrons that an atom has. Is it all right? Now all atoms are neutral in charge. So but electrons are negative in charge. So in case there are 10 electrons, so means the charge is minus 10. So to compensate to this minus 10, in case I want 0, I should have plus 10. Now plus 10 charge is of 10 protons. So means it has 10 protons. So number of electrons is equal to number of protons, as atom as a whole is neutral. Its total charge should be 0 and charge of an electron is equal to charge of proton. Is it all right? Now we are going to another very important thing that will be required. Electrons are rotating around the nucleus. There are certain rules by which we can find out that how many electrons are in which orbit. Maximum electrons in any orbit is 2n square. Maximum electron in any orbit is 2n square, where n is number of orbits. So in case I have got only one orbit, maximum electron in that orbit would be 2. In case suppose I have got 5 electrons, then first orbit can carry only 2 electrons. So remaining 3 would be in the next orbit. Now next orbit will also have the limitation. This is the second orbit. It can carry 2 into 2 square, which is 8 electrons. So second orbit can have maximum 8 electrons. Similarly third orbit can have maximum 18 electrons. So this formula you should learn, that maximum electrons in an electron is 2n square. Now there is one condition that you should learn, that last orbit cannot have more than 8 electrons. Orbit, if it is orbit number 4, orbit number 5, it cannot have more than 8 electrons if that is the last orbit. Is it all right? I think that even in 9th standard you have made electronic configuration of various elements. So let us try to revise that. Now first we will see of hydrogen. Now H stands for hydrogen. Hydrogen mass, atomic number is 1, mass number is 1, so it means it has only one proton. So one proton means one electron and no neutron, because mass number is also 1. So the first orbit will carry only one electron. So this is electronic configuration of helium for hydrogen. For helium, atomic number is 2, so first orbit will have both the electrons. So first orbit we say is complete, because first orbit can carry 2 and it is having 2. Now let us see second, third and fourth period things. Lithium, atomic number is 3, so first orbit will carry 2, 1. Beryllium 2, 2, because atomic number is 4, so 2, 3, atomic number is 5. So in this manner, this complete line I would say would have 2, 8. Now once this 8 has come, Now one more electron will come, second orbit cannot carry more than 8. So my sodium, whose atomic number is 11, has 281. Magnesium 12, 282. Aluminium 13, 283. Silicon 14, 284, and so on, and last argon 288. So argon, what is the atomic number? It is 18. So in case 19th electron comes, can it go in the third orbit? Third orbit can carry maximum 18, but it will not go because of this restriction that I have told you, that last orbit cannot have more than 8 electrons. So when one more electron goes, it will be in the form of 2881. So this orbit is still incomplete, but fourth orbit filling has started. So this is the electronic configuration of potassium. Then calcium would be 2882. Next electron is also gone in the fourth orbit. Okay, and third orbit is remaining 8. Now question comes, how long third orbit will not get filled? Only up to when the higher orbit gets up to 2 electrons. Once this gets 2 electrons, then the next electron will not go in the last orbit but will start filling this third orbit. So this you should learn. So now my next electron will go here, so it will become 2892. Then one more will come, it will become 28102. One more will come, it will become 28112. So how long will this continue? Till this becomes 18, because my third orbit can have 18. So once it becomes 28182, then once more will go, it will become 28183. So this you should note down and try to learn this, because this concept would be helpful in understanding periodic table. So I will give you 2 minutes. You make yourself electronic configuration and try to see this. So now we'll go to periodic table. You might be aware that there are 92 natural elements. Element means which are pure substances. They are made up of only one type of atoms. Is it all right? Now, before starting modern periodic table, I will give you brief introduction of how did this progress took place in this subject. See, initially, like suppose even you in case purchase many items for your household, then you will try to keep them in proper places. All pulses in one corner, milk in another place, sugar, tea in another place, so that when you require, you can easily put your hands on it. So similarly, when more and more elements were coming to light, so they thought it is difficult to remember the properties of all elements and properties. Can we make some groups? So initially, group was made into 2, metals, non-metals. With this, they thought that our purpose has not served. So then Daubigny made law of triads. He told that we can have 3 elements having similar properties, and he noted that the average of the extremes is the atomic weight of the atomic mass of the middle. Like calcium is 40, beryllium is 137, in between comes strontium. So if I take average of 40 and 137, I will get around 88. So he told that in case we keep the elements of similar properties in increasing of order of the atomic mass, then atomic mass of middle is average of the two. He could make these triads very few in number, so it was discarded, that it is not serving much purpose. Then came NEWLAND. He made law of octaves. His law stated that in case we write the elements in increasing order of atomic mass, then every 8th element will begin from any element that will resemble the first one. Like you are writing 8, suppose I take this shape. Now from here 1, 2, you are writing this 8 elements. They are in increasing order of the atomic mass. So then they are in increasing order of the atomic mass. So what he told, in case I am taking this lithium, then count 8, 1, 2, 3, 4, 5, 6, 7, 8. So properties of sodium will resemble the properties of lithium. You take beryllium, count 8, you will get magnesium. You take boron, you count 8, you will get aluminum. So this was NEWLAND's law of octaves. Okay, but this he could also do only for certain elements, few elements, not for all. And at that point of time all were not known also. So he could not put his law on a firm footing. But it gave some hint that yes, properties do resemble afters. But what is that law? So that law gradually got evolved. So this was the beginning of that law, you can say. That okay, 8th element is having properties similar to the first one. So then Mendeleeff took the thing further. He wrote all elements in increasing order atomic weight in a tabular form, such that in any group you will have all elements having similar properties. So if I take any group, means any this vertical thing, I have written various properties. Like suppose here, if I take all this in the same vertical line, then the properties would be similar. And he could arrange most of the elements known at that point of time, and he predicted also that in future you may find certain elements which will fit at these places of periodic table and they will have these properties. And this was found to be true. But there was a problem by arranging increasing our atomic weight. This got solved when Henry Mosley told that they are physical and chemical properties a function of the atomic number. So this is very important. So in case we do similar thing as well Mendeleeff has done by using atomic number as the basis, then our table would be perfect. So this is the presently accepted periodic table. So this table is in our syllabus. Later on, Neil Bohr modified to long form of periodic table, which I will be explaining soon. So this is the introduction for this. Now we will go to periodic table and see. Now first I will give you few minutes. You observe this periodic table and tell me, like if I give you certain drawing or a certain statue, I say to observe, you will see that this is having this thing, its tail is long, this is in this manner, it is quite bulky. So you observe this and let me know what you feel about this table, what you can observe here. See, first observation would be that there are 7 horizontal periods. They are called periods. So these horizontal things are called periods. So first observation is there are 7 periods. Okay, so there are 7 periods. This is my first observation. Then how many columns are there? Vertical. So there are 18. See the last number, 18. So there are 18 vertical columns are called groups. So there are 18 groups and 7 periods, and below the periodic table we have got 2 series. This is called lanthanide series, this is called actinide series. We are not just observing what this table is made up of. So we can say modern periodic table has 7 periods, 18 groups and 2 series at bottom of the table. Fine. But you will find that from period 4 and 7 there is something in the middle, but here there is nothing in the middle. So the number of elements written in between the two, now just learn the name, I will explain you after some time. They are called transition elements. So between period 4 and period 7 we have transition elements. So this is the structure of periodic table. Now let us go to the properties. I made you write electronic configuration of all elements. Hydrogen, what was written? Only 1. Isn't it? Hydrogen having only 1 orbit, and hydrogen is having only 1 orbit and only 1 electron. Then, so the helium is here. It is having only 1 orbit, and to complete an orbit we require 2. It is having 2. So it's